Okay, so welcome everybody. My name is Dr. James Haworth. I am the Program Director of the GIS and Computing route of our Geomatics MSc programs. And we're going to give you a bit of an overview of our programs. At various points, I'll pass over to my colleagues and they'll introduce the courses that they're responsible for. Okay, so who's here today? We've all done our introductions already, so we don't need to go through this again, but we have three Geospatial Sciences Program Directors. Then we have Professor Cheng, who is the Spatial-Temporal Analytics and Big Data Mining Program Director. And keeping everything going smoothly today is Emma Whitney, who's our Communications and Marketing Manager. So what we're going to talk about today, first of all, about why you might be wanting to study at UCL. And then I'll go through the Geomatics MSc programs. We'll talk, first of all, a brief overview of what the courses are and things like entry requirements and fees. Then we'll go on to the Geospatial Sciences and the different routes that we talked about just now. Then I'll pass over to Professor Cheng, who'll briefly talk about the Spatial-Temporal Analytics and Big Data Mining MSc. And then finally, I'll finish by going through a few of our modules and options and what you'll be studying depending on which MSc program you are going to take. And I'll talk briefly about dissertation. And after that, we'll convert this into a kind of chat room session. So there'll be lots of time for you to ask questions via chat, and we can answer those, and then we'll put a transcript up online of all of those. Okay, so why study at UCL? So hopefully the reason that you're all thinking about applying for UCL is because you know that we're a top-ranked university. So we're consistently in the top 10 of universities around the world according to QS. In the most recent statistics, we went up a bit to 8th in the world. Notwithstanding the current situation with coronavirus, London is actually an excellent place to study. So we've again been voted the best city in the world for students by QS in 2019. A couple of pictures there. One of them is the UCL main quad, that grand looking building there. That below that picture is a picture of Regent's Park during the winter, so frozen lake. We don't often get that, but you do get all weathers when you come to study in London. And finally, the map there with UCL pointed out shows that we're right in the center of all the main attractions in London. A very short walk from the British Museum. So there's lots and lots to do while you're not studying hard on the program. Okay, so hopefully you'll have found this information on our various prospectus pages, but if you're going to study here, you will have a minimum of a upper second, so a 2-1 degree in a relevant subject. So usually people will come with things like surveying backgrounds or geography backgrounds, but we're open to discussions about that. We hope that you will have some kind of mathematical and computational skills coming into this, and I'll talk a bit about those prerequisites in a second. We do also accept applicants on the basis of work experience. So if you don't meet the academic requirements, but you have had a few years working in a relevant industry, then we're happy to consider that. And we have obviously English requirements if English is not your first language. We have some preparatory work. So I mentioned the kind of academic requirements by regulation, but we also hope that you will have time to do some preparatory work before you come here. So our MScs are very technical. We don't teach basic GIS. We assume you have some background in GIS, whether that's using ArcMap or QGIS or one of those packages. It helps if you come with some experience in programming, and we'll share some resources for you on that. So that will come up relatively soon. We're updating it in consultation with this year's students based on what they think you need before you come here. So please do pay attention to that. We find that people who have done that work before they come here perform much better, especially in the early stages of the course when the learning curve can be quite steep. So fees, again, all this information is on the website. If you're a UK student, then the fees are $13,640. Overseas, they're roughly double that. And if you're a UK resident or a resident in England, sorry, you should know that you can get funding for postgraduate study, and there's some details of the website there. Okay, so this is about Geomatics MSc courses. We broadly have 2 MScs in the Geomatics section at UCL. So we have our Geospatial Sciences MSc, within which we have 3 routes. I'm in charge of the Geographic Information Science and Computing route. And then beyond that, we have the Building Information Modeling and Surveying route. and we have the hydrographic surveying route. So you can also join us with the standard geospatial sciences route, and then pick and choose from the other routes. When you arrive, there is some scope for switching between routes, with the exception probably of hydrographic surveying, which will require more of an in-depth discussion with Dr. Jonathan Iliffe, because that's much more specialized. Then we also have the Spatio-Temporal Analytics and Big Data Mining MSc, which Professor Tao Cheng is going to talk about soon. So if you're coming here and you're thinking, I've done a geography degree or a related degree, and you're not quite sure exactly what geospatial science is, we think of it as the science of working with geospatial data, so data with a geographic location, perhaps a timestamp, and we work through the whole process from acquisition to analysis. So starting with acquisition, it could be satellite, airborne, terrestrial data, it could be GNSS data, it could be hydrographic survey data, to processing. So we take that raw data, we work out how to represent it using a computer within a spatial database. We understand how to standardize the representation of that data so that the data you're working with can be worked with by other people, and how to report information on that data so that people understand how to use it. And then finally, depending on which route you do, you might focus more on the analysis. So what are the basic properties of spatial data that we need to understand in order to be able to work with it appropriately? So things like spatial correlation, spatial dependence, different methods for analyzing spatial data that are specific to spatial data. So lots of people might have data science degrees, but they will not have covered any of this stuff on analyzing spatial data, and they won't know how to appropriately do it. So I'll talk a bit more about that in a bit when I talk about the GIS route. So the thing that differentiates us from other, say, GIS related courses and geographic data science courses is that we do tackle the whole work stream from acquisition to analysis. So some MSc programs focus more on the analysis side, some focus more on the acquisition side. We work on the whole work stream, and depending on whether you're doing, say, hydrographic surveying or building information modeling or GIS, you'll focus more on one aspect than the other. Okay, so this is just an overview of the Geospatial Sciences course. And then within this, you then specialize in the routes, which we'll talk about next. So the course aims to train you in the theory, tools, and techniques of geospatial science, to equip you for a professional or research career in geospatial sciences. So we recognize that some people who do our courses will want to stay on and do research, for example, a PhD, whereas some people will want to go straight into industry and get a job. So we have lots of content within our course that focuses on gaining employment, for example, having industry speakers in, often who have done the course themselves, and we're also accredited by the Royal Institution of Chartered Surveyors. And they have, they mandate certain things that have to be within the course to enable you to leave as professionals who can work in that industry. Then within the routes, we have in-depth training in specialist disciplines. So we have the route that I'm responsible for, GIS and Computing, BIM and Surveying. BIM is becoming a very big industry now, so there's lots of demand for that. And Hydrographic Surveying, we're the only, as John's going to talk about later, we're the only Cat A accredited course in the country. Modes of delivery, so we have the standard lectures, computer labs. A typical course would be 2 hours of lectures and 2 hours of computer labs per week. Then we also have seminars and fieldwork, depending on what courses you're taking. We do have lots of coursework-based assessment. So we have individual and group coursework. I would say in general, our courses are not heavy on exams. We do have one particularly large exam that you will do in the exam period, but if you're not a big fan of exams, you might like studying here. And you'll learn lots of software. So as I've said before, we're a technical course. We focus very much on applying the methods. We teach the theory, but we need to make sure that you can apply them to real data and real scenarios. So some software you might have heard of, like ArcGIS and FME. You'll use those. We won't teach them necessarily from basics, but you will use them. We use a variety of open source software, including PostGIS, Postgres, Quantum GIS. all of these open source software packages are very useful because you're guaranteed to be able to use them when you leave. You won't need a proprietary license for those. And beyond that, we also teach various programming languages. So everybody learns Python in the first term. Python is the main language used within the geospatial industry. It's the language that underlies scripting in ArcGIS and in QGIS. It's also used very much for spatial data analytics. So it's very much the language to learn if you want to work in this industry. While you're here, all software is available free to use, mostly at home as well as on cluster machines. Okay, so now I'm going to talk briefly about the GIS and computing route, and then I'm going to pass over to each of my colleagues and they're going to talk about their routes. So the GIS and computing route focuses on geographic information systems and science. So there's a distinction between the systems, which is the software that we use. So many of you may have used things like ArcGIS. And we also focus on the science. So what are the actual ways of representing and modeling and analyzing spatial data? And how do they differ from methods that you might use for other types of data? So we go beyond desktop GIS. We do have some desktop GIS within the course, but we focus mainly on tools that let you go beyond what can be done in desktop GIS. We talk about data processing, analysis, and geocomputation. If you choose web and mobile GIS, you'll do some software development, some app development. You can also focus on spatio-temporal data. So lots of data these days has a timestamp as well as a spatial location. So it's very important to understand how to deal with that data because we can understand how things evolve in time. And we always focus where we can on applications to real data. I'm about to pass over soon, so good that my voice is starting to go just when I'm going to pass over to one of my colleagues. But we like to focus on real data, so we have lots of applications in transport, crime data, environment, so that when you go and start a job working with these tools, you'll understand how to immediately apply what you've learned to a large data set. So why GIS and computing? So I think that the current situation with coronavirus is really bringing to the forefront of our minds why geography is so important. Because we have something that's spreading globally and it's intrinsically linked with spatial location. And it's linked to transport networks, whether they're local or international travel. It's linked to government policy, which varies by place to place. It's linked to the underlying characteristics of the population. What type of, what's the age structure of the population? What type of underlying conditions people have? It's linked to how different places report the cases. So some people do more tests than others, or some countries do more tests than others. All of these things vary by space. And it's really important that we have methods that can account for these changes in order to properly understand how these processes are working. Most data science or computer science degrees won't give you this information. That's what we try to do. We try to equip you with techniques that can vary by location. So I'm now going to pass over to Jan, who's going to talk about the building information modeling and surveying, and I'm going to go get myself a glass of water. Thanks, Jan.
Thanks, James. Yes. So welcome everybody. I'm going to talk about building information modeling and surveying. So first of all, what is building information modeling, or BIM in short? It is the principle or the process that brings together different disciplines to enable better delivery of construction projects. So what are the different disciplines? They could be architecture, civil engineering, construction engineering, but also surveying and GIS. Integrate those disciplines using digital technology to deliver better buildings, better infrastructure, better rail, better roads, and so forth. We're really focusing on the geo-end side of things. So how can we actually bring surveying data and GIS data and enable surveyors or GIS specialists to integrate themselves with the BIM process? You might also know this under different terms. So for example, digital transformation is a term that is used to describe the transformation of the businesses out there to go into the digital process of BIM. A digital twin is a more technology focused term on how to deliver smarter infrastructure or smarter cities. On this course, what students will specialize in, or what they will learn, is reality capture. So the capture of mostly 3D data from reality, digitizing real objects, bringing them into the computer in order to do planning, refurbishment, or other processes digitally. Reality capture encompasses photogrammetry, laser scanning, and high precision GPS measurements. We have specialized courses on BIM, which focus on the geometric and semantic aspects of BIM. So how do we turn reality captured data into BIM-capable model, enrich them with information, and use industry-standard tools such as Autodesk Revit to kind of create appropriate model, appropriate to industry standard. We also talk about how to integrate GIS and BIM data, how to do the integrated management of such data, long-term storage of BIM models, and geospatial data. Apart from these courses, we share a lot of content with the general geospatial route. So students on this route also going to learn geospatial programming, Python, which is not only underpinning like the scripting in GIS programs such as QGIS or ArcGIS, but it's actually also the scripting language for tools such as Autodesk Revit. So Python really is the universal language for scripting these days of tools. And if you want to be really efficient in your day-to-day production, you want to automate the low-level tasks using very simple scripts, it's really important that people learn this skill. We also teach some very specialist skills in surveying. So people do get a module on actually going out there with total station, with a GPS receiver to capture some data. We still believe it's very important to know where your data comes from, to learn about quality of data, to have a realistic expectation of data before you then go and turn them into higher level outputs or higher level products. And of course, we learn about 3D geometric modeling in various modules. Applied BIM is one module where geometric modeling is key, but geometric modeling plays a role in many of the different modules that we teach. So on the next slide, you could switch over the next slide. I think on the next slide, I just want to two instances of images for outputs that students have created just this term, so from January to March. So the top left image, that's actually a survey using a state-of-the-art laser scanner, Leica RTC 360. So this is some 16 scans that students were taking throughout the building. So you see the red triangles, that's the stations, and in white, that's sort of the high-density point cloud that they've generated. And then to the right of it, that's one of the models that the students have created from laser scan data. They were actually presenting these, results, their outputs today in class. So you see the very highly detailed and high-level outputs that you can create with state-of-the-art BIM tools. One question, of course, if people spend a year on learning new skills and getting an MSc degree, is what can I do afterwards? What is my career going to look like? It's very difficult to, of course, predict. It's always a very individual choice. I'll just give you 3 examples of recent graduates from our course. Salendra, who basically returned to his home country and is now employed there at the National Mapping Agency. So he's from the beautiful island of Mauritius, and basically bringing his BIM knowledge back to his National Mapping Agency, where they're now trying to create detailed model of the houses. Ben actually is now a surveyor. He runs his own surveying office, specializing in laser scanning and BIM modeling. Akata, who was kind of the first graduate of our degree, she is now a BIM specialist or a BIM manager at Gatwick Airport, managing their facilities digitally, turning laser scans that suppliers bring into models, or even not even modeling these days anymore, but just purchasing models from subcontractors and integrating them into their BIM platform to run the airport more efficiently. So the wide variety of choices, government jobs, you can start your own business, or you can join larger asset management, asset owning organizations with this degree. So that's my quick run through the route of building information modeling and surveying of the MSc degree. And next up is going to be John Iliffe talking about hydrographic surveying.
Okay, so hopefully you can all hear me there. If we get a thumbs up from some of my colleagues, just to reassure that. Thanks very much. So this is the specialist hydrographic surveying route. What needs to be said about it? I mean, generally, it's a very broad-based program. So when we talk about hydrographic surveying, we're talking about offshore, rivers, ports, harbors, coastal environments. We're not confining ourselves to any one particular area. I think that's an important point when I emphasize that we do this with the Port of London Authority. That doesn't mean it supports an inshore kind of course. It's a very broad-based one. And a lot of the Port of London people have got experience from other environments, and we bring in people from companies like Net Survey and Sonodyne and so on to get the full range of people contributing to the program. And then on the actual kind of techniques, the processes and so on, it's everything. It's you know, you can be on a boat with acoustic sensors and be launching a drone from the deck. And with photography and have vessel-based LiDAR, and it's all about just a very broad-based view of all the different kind of techniques that you're going to be acquiring data with, and also the environments that you're going to be in, whether that's the you know, looking at analyzing the tides or the acoustic properties or whatever. So you can see all the stuff there online. And I think the thing that really needs, I suppose, emphasizing about why study this one, I guess, is it's most obviously it's a category A course accredited by the International Hydrographic Organization. That's becoming a very rare accreditation nowadays. So it's a good thing to have. And it's done in collaboration with the Port of London Authority is the other thing that really makes this course stand out around the world. And the Port of London is not the biggest port in the UK in terms of sort of volume. There's some very, you know, I think Immingham and places like that are bigger, but it's one of the most complex environments, and they have a very, very sophisticated hydrographic team. It's certainly the most advanced hydrographic team really almost anywhere in the world, I think. So they've got several fully equipped survey vessels, and the students are involved in using those and everything. James, could you go down to the next slide for me? Thanks very much. So there's just a few kind of images picked out from there. The rather hilarious sort of underwater Ziegfeld Follies picture at the bottom there is the students receiving their training in personal survival techniques. So there's an emphasis throughout this that all the students within the first few weeks of coming on the course are certified for in personal survival techniques. It means that you're getting much more employment ready, and you're able to collaborate with other companies and so on with this kind of certification during your projects and so on. And then the gang on board the ship there on the top left are taking part also in the Introduction to Nautical Sciences, which is again a requirement of the IHO. It's making our guys not just very sort of competent in mathematics and geospatial stuff and everything, but they're not going to look stupid on boats. Okay, so they know about boat handling and knot tying and meteorology and the rules of the road and the forecasting and all of these basic things, and so there's an extra course that's put on for the students, which is underwritten. The cost of that is actually underwritten by Norbit, which is an equipment manufacturer. So they're realizing the importance of this. They have sponsored the cost of that additional training on nautical science. And I think just about on the right-hand side there, you can see, well, actually it's one of the smaller of the vessels that are used by the Port of London. And so their students have this term been having various boat days. And then of course they've all been planning to come back in May for a continuous 3-week field course with a very, very substantial practical element there to survey for a project, and that's been thrown into a certain degree of doubt, shall we say, but we will deliver that at some point, probably towards the end of the summer. But that, in principle, is what the students are aiming towards. Once they've done all the taught elements, it's a requirement of the IHO that they're given a very substantial project to undertake, and they've been planning and submitting documents and that, discussing it throughout this term. I think that gives you a bit of a flavour. Maybe I should stop talking and hand over to probably Tao or somebody. And but looking forward, if you've got any questions about everything, then I'm around. So I'll answer those later on.
Hello, good here I'm afternoon. Okay, hello. Of course, someone is in the evening or in the early morning. So you already heard a lot from my colleagues about UCL, about their course. So what is the major difference between this spatial temporal analytics and big data mining with others? I think you will say not hugely, because fundamentally we're studying about spatial data, but also we call the temporal data. So we call them all geotagged or geolocated and time-stamped. So the reason for that, as you know, all data set nowadays with smart sensors, with all the GPS devices, they're all geolocated and time-stamped. So they're relevant to your Oyster card, smart transport card, or bank card, or smart meters, whatever you can think of. Okay, so that's the reason we have this special program for this. So what's the difference? Basically, there are lots of data science program. So how ours is different of them, because we focus on spatial, okay? We call spatial is special, okay? So that's James already mentioned it a bit in his talk. More importantly, we listed here spatial data, they are heterogeneous. That means to say situation in other place, in different places are different, like coronavirus. China is cooled down, and Europe is in the center of the outbreak. So that's heterogeneous. Of course, the dynamic, they're changing every day. However, you know where it come from. So it started from one place to go to other places, so they're interacted, they're all associated. Of course, we're talking about data now, the volume is increasing, and all of them relevant to human behaviors. We just use the coronavirus, can really kind of wrap up what kind of the question we are looking here, okay? This is one example, of course, transport, crime, and also environment, all the typical topics we are studying relating to spatial temporal data. So that's why, yes, a lot of data science programs, they look at data purely, mostly from most of them time series, but we look at them integrated space and time. Because like right now, all of us virtually together, right? And we are different time, but we are linked by the same, we're different location, but we are linked together at this unique time, okay? So that's why space and time got to be integrated. So here I want to just give you some examples. James already showed you other examples. So this one, because nowadays we have to talk about this, machine learning, AI, right? I just want to give you some flavor of what we could be done if we learn some techniques in the course. So this is one example. We use machine learning so to do crime prediction. So what it does, so basically we think about all the crime happened around the world, or actually it's related to, we try to model the world into a road network. So no matter how the world is represented, we're all connected somehow through the road network. So the crime also happening on the road network. So we model them as a graph, okay? Then we use what we call the graph deep learning. And then what we can do, we can make a prediction of the hotspot of crime. So what is really showing here, what's the accuracy if we use deep graph learning, and this is just use some standard. Also, that's a technology you're going to learn in our course called time channel density estimation. So this you can say that the accuracy difference. So what here is showing really say that's what is red colors really shows where the crime are in the past few months. But then the blue dot is a dot actually say, oh sorry. So the red line because just going south. The red line is really the hotspot we pick up, and the green dots appearing on those this hotspot, all the crime really happen on those hotspots. And the blue dot really just say, yeah, those all the crime also happen all the way. Yeah, there are a lot of showing really on our hotspot. Okay, so what does it mean to say this is the top 10%? What do we want to do here? We want the police can focus on the hotspot. So that means to improve their efficiency and effectiveness. So if more crime really happen on those hotspots, if police actually really patrol on those hotspots, that means they can stop the crime happening, or if it really happened, they are close by, so they can capture the criminals much quicker. So that's the purpose for this. So the principle of this deep learning method actually has been also applied to do traffic incident prediction and fire incident prediction. So there's lots of applications if we talk about smart city nowadays. So this is another example. I want to show the breadth of the work we could do. So this is also another PhD student's work. So what here really shows to say, you know, there's lots of slums, which in Chinese word is 城中村. Okay, there are lots of slums around the world, even in most developed the countries. Okay, like in Shenzhen, you may say it's very big, nice, very modern city, but lots of slums in the middle of the city. Okay. Even same in Beijing, of course, lots happening in other developing countries as well. So this is, we use the, again, we try to representing the reality into what we call the networks, and then we learn from some existing data. So we know in those areas, they are slums. So we learn from them, and then we build a model. So we're able to predict where other slums could be. Those places, quite difficult to map them and have low data. So that means we go from low to unknown. So that's what machine learning is supposed to help us to improve our knowledge, right? So I think is mine as well, James?
I can take over again now, Tao.
Yeah, so basically I just say those two slides just give you very, very simple flavor of what we could do. Okay, so of course there's more things we can do. If you're interested, we have our website, of course. I mean, we've talked a lot already. So most of courses in space-time analytics kind of associated with GIS course, and also space-time analytics. Basically, we have more close connection. We want the most advanced student learning more computer science program, and also we have courses associated with CASA, and also with geography. They're on some social media mining and also urban simulation. Thanks, James. I'll pass back to James.
Thank you, Tao, and thank you, Jan and John. So that's an overview of the 4 different MSc courses you can do within the Geomatics group at UCL. So I'm just going to quickly talk about the structure of those programs because there is some overlap between them. I'm not going to go into detail over the modules, but I just want to show you the different routes and how they manifest in what kind of topics you'll be studying. So in term 1, there is overlap between all 4 of those courses. So everybody does Geospatial Science and Geospatial Programming. We think that it's really important that everybody gets a background in programming because a lot of roles that you will go into after you graduate will involve some programming somewhere. Then we have compulsory modules for the different routes. So both GIS and STA do spatial analysis and geocomputation. That's with me. So that's learning how to map data using our statistical package and learning about the basic ways in which we can measure association, we can visualize spatial data, and we can create regression models based on spatial data. And we do that in the context of house prices forecasting. We then have spatial databases and data management. This is for GIS students, but STA can also do this. This is learning how to represent spatial data in a database, really important when you want to start working with large amounts of data. And then we have 2 courses which are both for the building information modeling and the hydro students, so engineering, surveying, and data analysis. And those give the students a really strong background for the specialist modules in the second term. If you're not on one of those pathways, if you're not doing the GIS or the or the BIM or the Hydro route, then you can choose freely within those modules. But what you'll probably find is that you'll be working down one of those routes, so you may wish to specialize. So that's term one. Term one runs from September to December, and then after Christmas in term two, there's much more flexibility in what you choose. There's a range of modules there. In the brackets afterwards, you can see which programs they are for. I won't go into too much detail here, but there's opportunities to also choose modules from other departments. So some of our students this year have done things like urban simulation, agent-based modeling from CASA, environmental GIS from geography department. So this is a case of where you can really decide to do something that you're interested in alongside the core content of the program. I won't explain that in detail because it will take some time, but if you have questions on any of those modules, then you can ask in the chat afterwards and we can direct you to the relevant pages, and we're happy to answer questions offline on those. Term three is where you do your dissertation. So that's May to September, but a lot of students decide to start a bit earlier than that. So after the Easter holiday. The dissertation is a large project of around 10 to 12,000 words. This is often done in collaboration with an industry partner. So we've got some strong links with various partners, including engineering consultancies, local authorities, government partners. This year we've got projects with Ricardo Energy, WSP Group, I think, and various others. You can also decide to do something linked to a research project that's going on within the department. So our academics have ongoing research and they always have projects that they would like MSc students to work on. You're also free to propose your own topic as well. So sometimes people come and they're maybe doing a part-time MSc with their company. We can discuss doing projects that are linked to your company. You may also have come in with a particular idea in mind of what you would like to do your dissertation on. And you can essentially pair up with a supervisor and discuss that topic. And if it's a viable research topic, then you can do that for your MSc dissertation. We have a strong focus on careers development. So we have a series of industry seminars that run throughout the year, organized by Claire Ellel, who's one of our academics. A lot of the time, these are run by students who have taken our courses before. So either the current Geospatial Sciences course or the previous incarnation in Geographic Information Science, or our surveying or hydrographic surveying courses or BIM courses. They're really keen to come back and talk to us because they recognize what a strong degree course we have here and the strength of our students when they graduate. So we really hope that you will engage with those seminars when you come here. Our Geospatial Sciences courses are accredited by the Royal Institute of Chartered Surveyors, and we have various courses which are linked to professional development, which you will do as part of the course. So we have courses on consultancy, for example, and various other things that will help you to become a professional when you leave here. So you can go straight into a technical role and understand exactly what you need to do to be a professional in the industry. Alongside that, we run things like career events. Sometimes we have people in to do mock interviews and CV reviews. We technically have a careers event organized. It was organized for April. It's going to be pushed back, but we will have one of those at some point, hopefully by the end of the year, if the coronavirus situation has improved sufficiently by then. And being in London, of course, there's always the opportunity to join various events across the capital. So lots of the big institutions are situated in London, and they run events quite regularly. And there's always other things, like we have a geo business event here where companies from across the geospatial industry come to exhibit their products and meet and network with people. That's free to attendees to come and visit them. We always have a stand there. Okay, so I'm going to bring that to a close now, so you've got plenty of time to ask questions. If you want to know more about our courses, hopefully you know this information by now, but you can visit our course page on the CEG website. You'll also, I imagine, be very worried about the coronavirus situation and the impact that might have both in the short term and over the course of the next year. So we have a link here on the UCL website which takes you to the latest advice. That's latest advice for people who are both studying already and prospective students. So if you go to sections 8 and 9, that will be kept continually up to date. But of course, if you have other questions that you need to ask, then we're happy to answer those. And if we can't answer them ourselves, then we'll pass you on to the relevant people.